Well, hello friends. Welcome to my new computer. This is QNCVS, computer built from donated parts that were sent to me by Quaker, Namshubbed, Charlie Horse 55, V. Koskiv, and Spencer. And I finally assembled all of the things that you guys have been sending me, and it works. We're here. And it's a really sweet and fast machine, especially compared to my previous one. And I just have to say thank you so much for sending me all these parts. It's amazing how generous you all are. So this is definitely going to be a productivity game changer for me, and I guess we'll just get started on using it, but I just wanted to say thank you to everybody who sent parts. So today we're going to work on kernel stuff, and there's this thing that's been irritating me for a long time about our kernel, which is in the system call interface. So if we go and look at, let's pick a system call, what's a typical one? Maybe something that you always do, like read, right? Like you're always reading. So in this interface, we have a pointer argument. It's the buffer. But the thing is that when we're handling the syscall in the kernel, then this is a user space memory pointer. And we really don't want to just use user space pointers willy-nilly in the kernel, because if we have some bug somewhere in the kernel, you might trick the kernel into copying something into user space memory that's really not supposed to be copied there, or you might trick the kernel into copying something from user space memory that's not really supposed to be there. And so one easy way to have such bugs is that we're just passing these around as if they are any other pointer, right? Like this doesn't look special in any way. It's just a unsigned 8-bit pointer. So what I would like to do today is to create some kind of wrapper template for these so that it becomes impossible to dereference them directly. And then we can still pass them around to functions that are known to do safe things with these pointers. So for example, we have the typical way you would use a user space pointer is that you would do copy to user, and then you would copy whatever data you want there. So like I'll copy something to this buffer, you know, my kernel buffer size, right? And I'm thinking we'll create something like a user space template like that, and then we'll have a copy to user overload that accepts this thing, so that you can still use it like this, but you couldn't do something like that. This would not compile anymore because we're not going to provide like a bracket operator and whatever. So just a way to sort of enforce that you only use validated and like secure operations on user space pointers. That's the idea today. So yeah. So first thing we'll do is we will add a template class for this. I think we'll call it user space, because I rather like that name. And then let's see. Actually we can try with this syscall first. So let's see what we do. User space U8. All right, and then this will have to be matched in the function declaration, of course. So user space, and we'll have to include ACK user space. Should we call it like user putter, maybe? User space has an interesting ring to it. I kind of like that. So let's see. How is this thing gonna work? Oh, it's a little big. So let's start with just saying namespace ACK, template type name, t class userspace, and then so here we will store it as a flat pointer. Types, yes, okay, and then you can create it using a flat pointer. Like that, and you can fetch it out like that. Okay, so this is just a start. We'll see what this evolves into. So how would that fare with our function there? So sysread. No template named userspace. Yeah, of course. Okay, so immediately it starts complaining that we can't pass it to things that take regular pointers. That's good. So we want to overload things like address validation functions so that they can accept user space pointers. I think what we'll do here is we'll just make an inline wrapper here. So we'll say something like and validate read putter. That seems generally okay, because it's okay to do these things. We just need to make sure that it compiles if you do. And this is more about like what's not allowed, which is basically everything is not allowed except a few select things. And then eventually, once everything is using the user space template, then we can get rid of the raw pointer versions of these things. But right now we have to have them. So okay, so that's good, and that means that this is now allowed, but we cannot call description read. Okay, so this is used. This one is a little bit iffy because it's also used internally by the kernel. Which is not super great for this particular thing that we're trying to achieve here, and it has a SMAP disabler and everything. So maybe read was not the best syscall to start with, because it's going to need a bunch more work actually to clean this up and make it not use a SMAP disabler. But yeah, so actually let's see here. Let's just do this with casting at this point. So U8 like that, and putter. It's a private member of ACK user space. Oh, right, of course. There we go. So this thing should actually be tweaked in the future so that read we should have a read that takes a user space U8, right? Something like that, but that will require a bit more work. Let's do some different syscall. That read was a bit of a weird choice. Let's do what's a simple to understand one? Stat. Stat is a good one. Okay, so stat, first thing it does, it gets all of its incoming parameters in this struct here, stat params, which itself is in user space memory when the stat syscall comes in. Because if we look at stat in the in libc, we can see that. Oh wait, where is it? Oh, it's here. No, this is not it. This is That's the stat program. Wait, don't. Where's the stat syscall? What the heck? libc uni_std. Oh, I thought it would be in stat cpp. Okay, so there's do stat, and then what we do is we build up this stat params structure in userspace, and then we send the address of that struct into the kernel. So we, in the kernel, receive one of these things. So we have to handle that. Now, how does that fit with the new template? So that means that we should take a user space const blah 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 like that. Oops. So let's see how this works out. Where is the thing? Here. User space. Okay. And then we call validate read and copy typed. So this thing needs an overload, which we can easily add. Just take a user space. Here, user space. Yes. And of course we have to actually okay. And then, so what happens here? So now we validate the user params, which is a user space thing. Let's see if this builds, by the way. Okay, so that's a good start. Now, this struct had a raw pointer in it. I don't love that. So let's also fix that and make it be a user space like this in the syscall interface itself. And this is going to make things a little bit weird, but let's see if we can work with it. So basically, for any pointer that we pass to the kernel, if we wrap it in one of these things, okay, so what do we have here? We don't have matching functions. First of all, we need a default constructor for user space. That's fine. And then we also need copy to user. So like that, and that should be okay. And then this just takes like that, and const t like that. Oh wait, forgot the t. This computer compiles so fast, by the way. It's like, I'm not used to starting a compile and it finishing so fast. Normally I have more time for thinking while it's compiling. But that's nice. I can get used to that. So here, okay, so now we have some issues. Now we can't validate the stat buff thing anymore because it's no longer a raw pointer, it's this thing. That's fine. We will just add an overload for this guy as well. So we'll say validate write to a user space, t star. And then we just cast. Okay, so now in the let's see, in the user space part now in libc, we can't pass the stat buff here. So this is just a raw pointer that was passed to the stat libc wrapper. But we need to instantiate a user space pointer. So maybe the easiest thing to do now is to just actually, what if we just let you do this? T term, but we say that if you're compiling the kernel, then we do that. But if you're not compiling the kernel, then we do this. And we could even store it here like this. So from the user space perspective, if you're using one of these things, then it just behaves like a raw pointer. And it should also be allowing implicit construction. That's not allowed. Cannot convert. Oh wait, what am I doing wrong? Oh, it's just a T. Right, it is already a pointer type. Okay, now all we have left is an emulator problem. Okay, well we can fix that. So in the emulator, we access the statbuf pointer. Okay, so this is kind of special because the emulator is pretending to be the kernel, but is actually compiling in user space. So what we have here is a user space pointer. But we're in the emulator. So maybe what we'll do is we will do this. And user space h, so if kernel, if defined kernel, or defined user space emulator. And actually this has to go before all of the includes. So statbuf is now a user space, that's fine. We just have to make sure that we do dot footer on it. I guess, yeah, that's okay. Okay, so does this work? Run something that stats. Yeah, stats seems to work. Let's run the ls in the emulator. That works too. Okay. I think I like this. And I like how simple it is. So let's see. Yeah. And it's nice how it's sort of transparent when you're using it in user space. So let's see, what else is here? So we have a string argument in here as well, and string argument internally has a pointer to characters. So what if we convert that thing too? So it looks like that. That's going to break more stuff, but we should fix it anyway. So let's see. Process CPP. Okay, so we got some red right here. No matching member, blah, 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 blah. Sure. Validate and copy string from user. So how about we just make an overload again? that just does this. Characters or user characters. Size. Okay, and then gets this called path argument, has the same problem. So we'll just make, again, another overload. Yeah, I don't mind adding these overloads since we're eventually going to get rid of them. So just do this, const char, user path, putter, path length. Okay, so then we have a bunch of places that are using these. Null checking. We can have definitely allow null checking on one of these pointers. That's okay. So that's an operator bool. We'll just do this, operator bool, const return and putter. For that, it doesn't matter if it's a T or a flat putter internally. Okay, so then in the emulator, at line 965. So what's going on here? We're trying to assign to path. And what are these things? Path characters is a const char star. It's path length. We cannot initialize a string argument like this. Wait, why is that not allowed? I would have thought that would be allowed. You don't like that because? String arguments requires one argument, but two are provided. Why do you require one argument? You have two fields, jerk. Okay, what am I not seeing here? Wait, back up. We're in the emulator context, so we're in the kernel, which means that it's explicit. Right, so, so we can't... Does this have to be explicit in the kernel? Maybe it doesn't have to. Wait, does that... Does that matter? You don't like that. Okay, fine. So if I do that, you want a flat pointer as the input. Is that the problem? Oh, shit. Okay. That's the problem. Right, I'm trying to pass it a raw pointer. This is a little bit weird. Yeah, this was going to get weird no matter what, because in the emulator context, we're dealing both, and this function right here. So we have one syscall se real path params. These are parameters from the emulated program. The emulated program is trying to send these parameters to the kernel. And then what we do is we intercept this syscall, copy out what the emulator is trying to send to the kernel, and then we make our own real path parameters for like the host machine that we actually send to the kernel, to the real kernel, and then we're doing both emulated parameters and native parameters here. So this was going to get messy no matter what. So let's just maybe I was like overly ambitious trying to use that define here, because userspace emulator is special anyway. Like he has to I don't know. Wait, that's not how you do that. Okay, so now it builds. Let's try to run it, and we come up, and we can't ls. That's a bit suspicious. Why can't we ls? Wait, what's this call is failing? Open. Okay. So vert open. And in the open params there is a string path. Okay. Path characters. It's this thing. Let's get rid of that thing, maybe. Yeah, it's like I don't know how to write this in a nice way. It's going to be weird no matter what I do, I think. So now we have a problem on 965. And 952. Wait, what's wrong with this? Cannot convert stat star to stat star star. Right. Okay, so the emulator breaks and open. Copy buffer from VM. Oh, why? Copy buffer from VM. So it's this call right here. Why is that failing? Let's log something beforehand. Or open, copying p size zoo. Oh wait, are we just casting to flat footer? That's probably selecting the operator bool. Is that what's happening? So I have to do that. Yeah, operator bool is can be a bit sneaky when you override it. Yeah, there we go. So maybe what we should actually do is also provide an operator flapper. So how do we do that? Operator flapper, flapper, frickin' operators. Otherwise, we're just taking operator bool and converting that to a flapper, which is going to be like 0 or 1, which are usually not great pointers. But now it just works. Yeah. So that's okay. So I think I quite like what we've ended up with here. Let's maybe convert some other syscall just to see what it looks like. Or you know what? Let's commit. So add this thing. Add userspace t a wrapper for userspace pointers. This will be used in the kernel to wrap pointers into user space memory without convenient direct access. This will help us. The idea is to help us avoid accidentally dereferencing user space pointers. Is to use the compiler to enforce that we don't dereference. English? That's not the best English, but So then let's get rid of that define that I was messing with there. Okay, and then actually that shouldn't be necessary either. So the cast, you should be able to cast a user space to a flapper and you can just get the pointer. So that's good. Yeah. Okay, so kernel. Use user space t for sysread and sysstat. Add validation helper overloads as needed. Yeah. Okay, so let's see what else we can do this with. We have, I don't know, I just want to pick some random one just so we can do something with someone. Change directory. Change directory, that's a good one. Shadir. Okay. So this now becomes a user space, and the overload is already in place. And will it just work? Yes, it does. Okay, so see how nice this is? Because this means that, hold on, let me switch this to kernel mode. This means that this was previously a const char star, right? Like you could do something really dumb, like even just doing strlen on it. And now you're reading from arbitrary user space memory, which we just don't want to do that. But this is no longer allowed. In order to actually do this, you would have to cast the internals of it to a const char star, like that. And this is very cumbersome, and so you're much less likely to do it. And if you do this, you're going to think about, well, why am I doing this, right? Like, In fact, maybe we shouldn't even have this thing at all, or we should call it something like much more much more awkward. Like we could even call it like unsafe footer or something, or I don't know. Maybe we'll make it private later or something. Just get it out of your face entirely. Let's call it unsafe for now. Or no, you know what? Let's just leave it as footer, and then we'll hide it later once everybody's using it. So let's do this one as well. Get current working directory. So here we have. Oops, what am I doing? We have copy to user. So this doesn't work. Hold on, let me update the declaration, user space. Okay, so copy to user needs a user space overload. Yes, it does. Okay. So we'll add those. Well, actually, I guess we'll add those down here because the thing that we added was the typed variant. These are arbitrary size variants. So let's see, inline test source. So this here is a user space size. Well, this is not userspace, right? This is in the kernel. So dest. Okay, this takes a little bit getting used to, but you can see how valuable this becomes, because it's not just that it enforces that you don't do stupid things, but it also actually documents very, very visibly in the code that this is a user space pointer, right? Like now it's super obvious when you're reading this, which I really, really like. So this just becomes a matter of saying dest footer, like that. Source and size. Test const void source footer size. This does not work. We have a user space char star and it takes a user space void star. Interesting. How do we want to approach that? Well, I guess one thing we can do here is just say template type name t, because it doesn't really matter. Like that. And then we'll just, we're casting to void star anyway, so as long as that works out, it doesn't matter. Because every pointer can be a void star, so who cares? Okay, so how does that work out? Well, the CD system call seems to work. Very cool. I'm liking it. I'm liking this a lot, actually. So, let's see, get CWD. Add more validation helper overloads as we go. Okay. Maybe we'll do like one or two more, but then I think you get the point. We're going to want to convert everything to be this way, but one thing at a time, obviously. So what's one that is different from the others? Symlink, maybe? Yeah. Let's do unlink file removal. That's I mean, that's just a path name. Okay, fine. Let's do something harder. Let's do utime. Changing the access time, change time, stuff like that of a file. So it has a path name, and then it has a buffer containing the new timestamps for the file. So right here. So you'll notice, by the way that I used to do all these things to try to tell you that what you're looking at is a user space pointer is I've been putting like user underscore at the start of names, but it's still like a frickin' const char star. So this was like a very, very thin layer of protection. This here is a much, much thicker, much better layer, I think. So this is, you can tell from my talk that I'm really liking this. Wait, what was that called? User buff. So, okay, buff, whatever. Because now we don't need those user things up front. We'll need an overload here. Path. Oh, wait, that was... We were using the name path locally here as well. Fine. Why don't we just call it that? And it's not that user was, it's not that the prefix was bad, actually. So we can actually keep it. It doesn't really matter. I think I was a little over-eager to get rid of it there. Validate read typed. Okay, so this guy needs an overload. That takes a user space. And validate read already has an overload, so we don't need to touch that one. Oops. But basically this should allow us to use the touch command to change the timestamp of something. So we'll make a file foo, and then we'll change this timestamp. And it changed. It works. Great. Yeah, I mean, this is just getting really, really straightforward. Now we're not even changing anything in the function itself. We're just changing the arguments. Kernel. Use user space d in sys utime. And again, another overload. Okay, so I think this is going to be it for today's video. So I just wanted to make something like this, and I'm glad that we have it now so we can spread its use and hopefully I don't know, maybe we'll catch a bug while using it. It will expose some bug somewhere, I don't know. It's going to take some time to use it everywhere, obviously. But I'm very happy with it. So thank you very much for checking out this video. I hope you saw something interesting. And thanks again to everybody who donated parts for this machine. This is an absolutely sweet machine, and I am so grateful to all of you. Thank you. And thanks for checking out this video. I'll see you next time. Bye.